In 4, we're asked to determine the equation of a plane that contains a line and the point. So, equation of a plane needs 2 directions and a point. Good news is we got 1 point and a second point, so we can find ourselves a second direction. We'll call that direction AK. So, vector subtraction, think of this as point A, okay? 3 minus 1 is 2, negative 2 minus 2 is negative 4, and 4 minus negative 3 is 7. So if I want to find the equation of this plane, you can pick a point, either A or K, your choice. I'm going to use A. And one direction for sure, the one we just found out, 2, negative 4, and 7. And the other direction, we're given the line, 1, 2, negative 1. Okay, now doesn't matter what order you put these in. You could put S first, then T, T first, then S. You could have picked point K instead of point A. As long as you have a point in 2 directions, it's all good. Okay, part B, we want to find the distance from S to the plane that we found. Well, the unfortunate part with the plane that we found right now is it's not a great form for distance. So we want to figure out the Cartesian form of that plane. For a Cartesian, we need a normal. Our normal is S cross D. So in vertical form, negative 4, 7, 2, negative 4, and 2, negative 1, 1, 2 will give us 4 minus 14, 7 minus negative 2, and 4 minus negative 4. So we'll get negative 10, 9, and 8. Now it's totally fine to use that version, or if you want to use the positive A value, which is what our book usually does. And now we got ourselves some Cartesian coefficients. And we're missing D. In order to find D, we have to use a point that we know on our plane. So I'm going to use a point that was given in our plane equation, though you could also use the point K if you want to, because we were told those both lie on our plane. So 10 times 1, I'm using this one, okay? 9 times 2, 8 times negative 3, solve for D. And so we'll get 10 minus 18 plus 24 is 16 plus D. So D is negative 16. So in Cartesian form, 10x minus 9y minus 8z minus 16 equals 0. Now the reason we were doing this was to find our distance, remember. So our distance from a point to a plane can be found using our absolute of our coefficients with the point filled in as your x, y, and z. So our point is 1, 1, negative 1. So 1 for x, 1 for y, and negative 1 for z, over the root of 10 squared plus negative 9 squared plus negative 8 squared will give us on top 10 minus 9 minus 8, or sorry, plus 8 minus 16, or a total of 7. Don't forget, we're going to take our absolutes afterwards, right? And on the bottom, we get the square root of 10 squared, 9 squared, and 8 squared. So I think it's about 245. Yeah. And then if you want to, you can change it to a decimal or not. I'm not really picky if you do that or not. Units. Okay. Back in the previous line, just remember you did take, this was a negative 7, right? We just took the absolute of this thing, which makes it always a positive.